Standard 2 is solving multi-step equations. Solving multi-step equations is all about using opposite operations to undo. First, we'll start off with some one-step equations, like this first one here, x plus 2 equals 7. You can probably already figure out that x has to equal 5 in order to make this work. You understand in your head that addition and subtraction are opposite operations. And if you subtract 2 from 7, you get 5. That means 5 plus 2 equals 7. But let's do this out using algebra. So 7 take away 2 is going to give you 5. And in algebra, it's all about balance. So if I take 2 away from 7 and get 5, I also have to write out that I take 2 away from this other side of the equation. And what's happening on the other side of the equation is the plus 2 and the minus 2 are canceling out. So all that's left on the left is an x, and then you have to bring down the equal sign. So that's the algebra way to show all the steps that x has to equal 5. You took 2 away from 7 because subtracting is the opposite of adding, and then whatever you do to one side, you have to do to the other. So let's look at this next one here. X minus 4 equals negative 9. So in this one, I'm subtracting 4 from x, so I'm going to have to add 4 to the other side because I'm using opposite operations to undo. And negative 9 plus 4 is negative 5. Same deal, I'm going to add 4 to this side. Negative 4 and the positive 4 cancel out, so x equals negative 5. Does that make sense? Negative 5 minus 4 does equal negative 9. So far so good. Now let's try some with multiplying and dividing. This next equation says 3 multiplied by some number x is negative 27. So the opposite of multiplying is dividing. So to undo that operation, I'm going to divide this side by 3. Whatever I do to one side, I have to do to the other. So I'll divide that first side by 3. Here the 3's cancel out like that. So you're just left with x on the left. And then negative 27 divided by 3 is negative 9. Here I have x divided by 4 is 3. The opposite of dividing is multiplying. So I'm going to multiply each side by 4. Multiply each side by 4. And you can turn this into 4 over 1 if you want to think about all the steps. So that means the 4's cancel out in the numerator and the denominator. Same deal, I'm just left with x on the left. Or x over 1, which is the same as x. And 3 times 4 is 12. What if you have an equation with a fraction in it like this one? You have 5/7 times x is 15. So you could divide each side by 5/7 to undo the multiplying, but dividing by a fraction is never a good scene. So what we're going to do here instead is multiply by the reciprocal. I'm going to multiply this side by 7/5, and then I'm going to multiply this side by 7/5. And on the left-hand side, the 7's cancel out and the 5's cancel out, and I'm left with just x. So you can see why multiplying by the reciprocal is a good thing to do there. It undoes the fraction in front of the x. On the other side, I'm going to turn this into 15 over 1. Cancel out the 5 between the 5 and the 15. That gives me a 1 there and a 3 there. So 3 times 7 is 21 over 1, or just 21. Next, let's do some longer equations. So it's all going to be about using the opposites to undo, except we're going to have to do it in a special order. So if you see parentheses there, remember back to PEMDAS, you do parentheses first. So I'm going to do the distributive property and take care of those parentheses. So 5 times x is 5x. 5 times negative 4 is negative 20. Plus 2x equals negative 10. Next, I'm going to combine like terms. I have 5x and 2x. Like terms means the variables are the same. So 5 plus 2, that means I have 7 of those x's. Still carry along the minus 20. Now, I'm trying to get x by itself, so I have to keep undoing things until I peel away everything but the x. Next, I'm going to take care of this 20. It's subtracted, so I'll do the opposite, which is add it. So these cancel out. I'm just left with 7x on the left. Over here I have 10. Now x is multiplied by 7, so the opposite of multiplying is dividing. I'll divide each side by 7. And I get for a final answer x equals 10/7. Now here's a fraction, here's an equation that's all full of fractions. You could go ahead and add and subtract all these fractions if you'd like, but there's a trick that makes equations that are full of fractions easier. I'm going to figure out what the least common denominator for all of these fractions would be. It looks to me like it would be 20. So I'm going to multiply each side by the least common denominator, 20. And on this side I'll multiply by 20. And what's going to happen here is all of the denominators will cancel out, and I'll be left with no fractions at all. So 20, I'll do out one of them over here, 20 times -1/4. So I'll turn that into 20 over 1. Cross reduce the 4 and the 20. So this first term turns into -5x. Next I have to multiply 20 by -3, which is -60. And then 20 times 2/5. Let's do this one out too. So 5 and the 20 cross reduce like that. 4 times 2 gives me 8, so this turns into plus 8x. And now I have to get rid of that thing, so eraser. So that's going to equal, on the other side, 7 over 20 multiplied by 20. The 20s just cancel out, so I get 7. So combining like terms, -5x plus 8x is 3x. Minus 60 equals 7. I'm going to add 60 to each side. And get 3x equals 67. Divide by 3, divide by 3. 3 doesn't go into 67 evenly, so I'm just going to leave it as 67/3.